Hello, let's take a look at some more right triangle trigonometry problems from the book. If the slope of AB is 5/8, then find the tangent of angle BAC. So we're asked to find the tangent of angle BAC there. The slope, by definition, is the change in y's divided by the change in x's, or the difference in y's over the difference in x's, or delta y over delta x. And then the tangent of angle, and I'm just going to call it angle A, is the opposite divided by the adjacent. So now when we look at the image, we know that the slope is delta y over delta x. And with respect to angle BAC, or angle A, we can see delta y is the opposite side and delta x is the adjacent side. And that is 5, that is 8. So the tangent, by definition, is the same as the slope. So the tangent of angle A is 5/8. Use the definitions of the trig ratios to find the following relationships. Well, I believe that we've done at least one of these in class, but we'll do it again here. So sine, I'm just going to use O for opposite and H for hypotenuse. Sine is opposite over adjacent. Cosine is adjacent. Did I say adjacent? Opposite over hypotenuse for sine. Cosine is adjacent over hypotenuse. So if we square the opposite side in the hypotenuse, add that to the adjacent side divided by the hypotenuse, then we can combine the opposite side squared plus the adjacent side squared over the same denominator, which is the hypotenuse squared. Now, let's think back to the Pythagorean theorem. If this is my angle, this is the opposite, this is the adjacent, and this is the hypotenuse. Doesn't the opposite side squared plus the adjacent side squared equal the hypotenuse squared by the Pythagorean theorem? So then I'm going to substitute opposite squared plus adjacent squared for hypotenuse squared. And then anything divided by itself is 1. Now, what is essential here that I glossed over is the word verify. Whenever you're asked to verify something, an equation, typically in an algebra context, that essentially is a proof. You can work one and only one side of the equation. Basically, the way I approached this was that this side was what I was given, and this side is what I needed to prove. So when it reads verify, that means work one and only one side of the equation. So we have to verify. Now, by the way, this is called the Pythagorean Identity. And this one is the law of sines. So, if we're looking at a right triangle, and we're talking about the sine of angle A, now that's angle A. This is the adjacent side. This is the opposite side. This is the hypotenuse. This would be B, and this would be C. That would make opposite angle A would be side A, opposite angle B would be side B, and opposite angle C would be side C. So then I have A divided by, remember, sine is opposite over the hypotenuse. So opposite from angle A is A, and the hypotenuse is C. And then B divided by the sine of B. So now I'm switching angles. So now B is opposite. And then my hypotenuse. So sine is always opposite over hypotenuse, but the leg can switch depending on the angle. So now when I have A divided by A over C, I have to multiply by the reciprocal. And I'm supposed to be working only one side, right? Let me roll with this and then I'll show you how to fix that. So then those cancel and those cancel. So now, again, I'm only supposed to be working one side. So what I'm going to do is now say C is equal to B divided by the sine of B. And then as long as I multiply something by 1, I haven't actually done anything inappropriate or wrong mathematically. So what I'm going to do here on the left side is multiply by B over B. Do you see how I'm kind of working backwards here? And then I'm going to change this to be B divided by B over C, and that'll be equal to the sine of B. So sometimes when you're asked to verify equations, you can use the lightning method, but you don't want to show that, so you usually want to do your work on another paper. And then we said B divided by C was the sine of B. And then here we have a reciprocal identity where the sine of A, I'll use this diagram, the sine of A is the opposite divided by the hypotenuse. Cosine is the adjacent over the hypotenuse. And then when we divide by a fraction, we multiply by the reciprocal. So those cancel. And we're left with the opposite over the adjacent, which is the tangent of angle A. Without using a trig table or a calculator, find the measure of angle A in each case. So this should be indicative that it's going to refer to one of the specials. So we know that tangent is equal to the opposite over the adjacent, which would mean that the opposite leg and the adjacent leg would have to have the same measure if it reduces to 1. That means that the measure of angle A has to be 45 degrees. Here we have a value of 1/2 for the sine of A, which means whatever the opposite side is, the hypotenuse has to be twice that. That should be enough to jog your memory to know that this is a 30, 60, 90 triangle. So we see that the measure of angle A is 30 degrees. And here we know sine again is opposite over hypotenuse. So if the opposite side is some value, some multiple of x root 3, or some multiple of root 3, and the hypotenuse is some multiple of 2, this should also be sufficient to have you realize that that's a 60-degree angle. If you struggled with any of those, I strongly encourage you to go back over the 45, 45, 90 and the 30, 60, 90 and absolutely, positively, without question, commit these two to your brain because you will need them at every level of mathematics from now on. Kind of like 1 plus 1 is 2. That's how those are assumed to be known. In each case, find x to the nearest integer. So, I'm looking at the opposite in the hypotenuse here. That means I need the sine function. Sine of 27 is equal to x over 40. Now, the first thing I want to do is put the equation in calculator ready form, which means I want to solve for the variable. So I multiply both sides by 40. And this is calculator ready form. So now that I have my calculator, remember the first thing I want to do is to check the mode. Because there are two ways to measure angles. One is radians, which we will be studying shortly. But right now, we are working with degrees. So we want to make sure that we are in degree mode. So now I can enter in 40 times the sine of 27. And it's set to the nearest integer, so I'll say 18. In this one, we have the opposite and the adjacent. So that's the tangent function. The tangent of 32 degrees is equal to x over 70. Multiply both sides by 70. And now I am in calculator ready mode. So on some assessments, especially the ones where you cannot use a calculator, you will be asked to provide calculator ready mode. That's what it means. So then I can go to my calculator and type in 70 tangent 32 into the nearest integer. We're at 44. And opposite sides of a rectangle are congruent and parallel. So you also could have just said this, those two angles are congruent, which would have made that 52. In either case, we are looking for the adjacent side and the hypotenuse. So that's the adjacent side, that's the hypotenuse. So here we have a cosine of 52 degrees is equal to x divided by 100. So 100 times the cosine of 52 equals x. And there's my calculator ready form. And then I have 100 cosine 52, or 62. And here's my rhombus. That is, if I just focus in on this triangle here, I remember that a rhombus has diagonals that are perpendicular and bisectors, but that's kind of irrelevant. So opposite of 23 is x, and then the hypotenuse is 40. So opposite over hypotenuse is sine. So the sine of 40 is equal to x. Sorry, did I actually do that? Be careful, don't confuse the angles and the lengths. The sine of 23 degrees is x over 40. So then solving for x, we can multiply both sides by 40. That is my calculator ready form. And 16. To find the height of the trapezoid, it says it's an isosceles trapezoid, which means opposite sides are congruent. And this is an altitude, so there's the right angle that I need. And I need that height. So now I have the opposite side and the hypotenuse. So I need the equation sine of 38 is equal to x divided by 25. Multiply both sides by 25 to get my calculator ready form. And then I go over to my calculator. And x is about 15. Solve each equation to the nearest integer. So to isolate x, right now x is divided by 40. To undo the division, I need to multiply both sides by 40. So that's calculator ready form. So x is about 17. Now, I need to isolate x, but right now x is in the denominator, so the first thing I'm going to do is multiply both sides by x. Then I have x times the cosine of 73 degrees equals 35. So now I'm multiplying, I need to divide both sides by the cosine of 73 degrees. So then my calculator ready form is x equals 35 divided by cosine of 73. Again, this is the calculator ready form where it's solved for x. And then I go over to the calculator, 35 divided by cosine 73, and I get about 120. Here I need to solve for x. Now, I did mention when we started this unit that there is not multiplication between there. Any trig function is referring to the ratio of the sides formed by that angle. So you cannot divide sine out. What we need to do here, we need an inverse function, something that will undo the trig function. And there's a series of them which essentially just have the word arc written in front of them. And then for the other three as well. This on your calculator is written to the negative 1. So to undo this, I want to take the arc sine of this and the arc sine of that ratio. Then these two cancel each other out. So my calculator ready form is now x equals the arc sine of 29 divided by 30. In Moodle, since we can't enter the exponent, you will need to type the word arc sine and put that in parentheses, please. If you were writing this on an assessment, you could write arc sine 29 divided by 30 like I have it, or you could write arc sine, with the negative 1 up there, but it's still read arc sine 29 divided by 30. So either one of these would be acceptable calculator ready form on an assessment. And to get to the arc sine on the calculator, I have to hit second sine 29 divided by 30, and I get about 75 degrees. A department store escalator is 80 feet long, and it rises 32 vertical feet. Find the angle that it makes with the floor. So here I have the opposite side is 32, and the hypotenuse is 80. So I need the sine of x equals 32 divided by 80, and I'm going to need to find the angle. Whenever you're looking for the angle, and yes, this is an intentional misspelling, you need to do the arc function. So whenever you need an angel, call on an archangel. When you need the angle, use the arc function. So now I know that x is the arc sine of 32 divided by 80. That's my calculator ready form. So the second sine of 32 divided by 80 is about 24 degrees. Find to the nearest degree the angles of a 3, 4, 5 triangle. So thankfully it's saying to the nearest degree, because that's actually going to make this a little bit faster. So if I say this leg is 3 and this leg is 4, then the hypotenuse is 5. And I'm looking for the angle. So I'm going to say the tangent of angle A, it doesn't matter which one you pick, I'm just picking that one, is the opposite over the adjacent. That means I need the arctan of 3 divided by 4. So second tangent, 3 divided by 4, is about 37 degrees. So angle A is approximately 37 degrees. And let's recall that in a right triangle, the acute angles are complements. So angle B would have to be 90 minus 37, which would be 53. And then that's 90. I want to take a moment to talk about angles of elevation and depression. They are always, always, always measured off of the horizontal, which is referred to as the initial side. So it starts initially on the horizontal. An angle of elevation will go upwards. An angle of depression will go downwards. Now, this graphic is okay, but I think I have something a little better to explain it. So, imagine two parallel lines. And then I'm going to put my triangle in here. So here is my angle of depression, and here is my angle of elevation. Now, if we think about this a little bit, we know parallel lines implies alternate interior angles are congruent. So that would mean that angle of depression outside of the triangle, because it has to be starting on a horizontal, would be congruent to that internal angle, which would be an angle of elevation. This is moving into angles of elevation and depression. So angles of elevation and depression are always measured off of the horizontal. So if it goes up, it's an angle of elevation, and if it goes down, it's an angle of depression. Sorry. So here, this 37 degrees is an angle of depression. The sonar operator on a cruiser detects a submarine at a distance of 500 meters directly, and an angle of depression of 37 degrees. We need to find the depth of the submarine. So from that angle, we're looking at the opposite and the hypotenuse. So the sine of 37 is equal to d divided by 500. That's the equation that I need. Then to solve for d, I multiply both sides by 500. So now 500 times the sine of 37 is about 301 feet, or if I'm going to one decimal place, 300.9. If I wanted to be really creative about it, I could subtract off the 300, taking just the decimal value multiplied by 12, and I have about 300 feet, 10 inches, or 11 inches if we round it. Maybe I should round it. The legs of an isosceles triangle are each 18, and the base is 14. Remember the properties of an isosceles triangle. When you drop down the altitude, it's also the median. Find the base angle to the nearest degree. So here I have the adjacent and the hypotenuse. So the cosine of angle A is 7 over 18, and I'm looking for the angle. So that means I need to use the arc function. The arc cosine of 7 over 18, that is the calculator ready form. It's second cosine, 7 divided by 18 is about 67 degrees. Set to the nearest degree. Find the exact length of the altitude. So this. If I need the exact, that means I cannot use a calculator. So I'm going to say the altitude squared plus 7 squared is equal to 18 squared using the Pythagorean theorem. So a squared is going to be equal to 18 squared minus 7 squared. Well, I am going to use the calculator for that part. 18, I forgot where the squared is. Minus 49 is 245. So looking at that, I can see that 5 goes into there. And I get 49. So then a is equal to the square root of 49 times the square root of 5. And I know that the square root of 49 is 7. So that would be the exact length. Here is some more indirect measurement using elevation and depression. Two buildings are 100 decimeters apart across a street. A sunbather at point P finds the angle of elevation to the roof is 25 and the angle of depression is 30. Find the height of the taller building. So I'm going to do this in two parts. First, I'm going to find the length A, which is here, and then I'm going to find the length B, which is there. I know that this is essentially, or I'm assuming at least, that that is a rectangle, so that would also be 100. So then I'm looking at tangent because I have opposite and adjacent. So the tangent of 25 is equal to A divided by 100, which means that A is equal to 100 times the tangent of 25. Similarly, the tangent of 30 is equal to B divided by 100, which means B is equal to 100 times the tangent of 30. So if I want the calculator ready form for the height of the building, I need to add A and B. That would be 100 tangent 25 plus 100 tangent of 30. That's my calculator ready form. Where'd it go? So now 100 tan 25 close plus 100 tangent of 30 is about 104. And I'll put the unit in there. An observer on a cliff. So there's our little stick man. Is 1,000 decimeters above sea level. And he sights two ships. So there's boat 1, there's boat 2. At an angle of depression. Now remember, depression is always off the horizontal. So one angle of depression is there, the other one is there. So the larger is 47, and the smaller is 32. And when I say the larger, I mean that whole span. If these are parallel, then alternate interior angles are congruent, and that's 47. And then that's 32. Find to the nearest decimeter the distance between the ships. So I'm going to need to do this in a couple of different parts. There's A, and that whole thing is B. Then the distance between the ships is going to be B minus A. So I'm looking at the opposite and the adjacent. So that means I need the tangent, and I'll go from this angle on the bottom here. So then this is the opposite side. The tangent of 47 degrees is equal to 1,000, the opposite, divided by A. And the tangent, well, if I have to subtract, shouldn't I put A on the right? I have to subtract B from A. Makes more sense. The tangent of 32 degrees is equal to 1,000 divided by B. So now I have to multiply both sides by the denominator and divide by the trig function. So B is equal to 1,000 divided by tan 32, and A is equal to 1,000 divided by the tangent of 47. So then the distance between the ships in calculator ready form is 1,000 divided by tan 32 minus 1,000 divided by tan 47. So about 668. So this is the calculator ready form, and this is the estimated distance. And our last example. Find the height, PB, of a mountain whose base and peak are inaccessible. So in other words, let's make this a blue triangle, I can't measure. If I'm standing at A, I can't measure the distance to B because I can't walk through the mountain. And this is 30 degrees, and that's the height. And then let's look at this red triangle here. That's still going to be the height of the mountain. It doesn't matter. The mountain doesn't grow or shrink if we move. So the height will stay constant. So if we let this value, AB, be x, then this out here becomes x plus 1. And we're looking at, in both cases, the opposite and the adjacent legs, which means we're going to need the tangent function. So the tangent of 30 degrees is equal to h over x plus 1, and the tangent of 35 degrees is equal to h over x. Now, I notice that h is in both of the equations. So what I think I want to do is solve for h. So I have the tangent, well actually x plus 1, because that'll be a number, times the tangent of 30. And if I solve them both for h, I can set them equal to each other. Now, the tangent of 30 is square root of 3 over 3. But I don't know what this tangent of 35 is, and I don't really have a means to find that. So what I'm going to do is I'm going to use the calculator. So the tangent of 30, and it's pretty traditional just to go to 4, rounding to 4 decimal places. So x plus 1 times 0.5774 is equal to x times the tangent of 35, which is 7002. Now this looks a little weird, but I'm going to distribute that. 0.5774x plus 0.5774 is equal to 0.7002x. Then I am going to move all of my x's over to one side of the equation. And now my equation reads 0.5774 is equal to, let's take 0.7002 minus 0.5774, 1228. And now I need to divide by the coefficient of x. It 5774 divided by 0.1228. So 4.702 is approximately x. But what was it asking? Find the height, the distance. So I'm just going to go back to my red triangle because that's what x is, 4.702. And my height is unknown, and in the red triangle, this was 35 degrees, so now I need to solve for h. So I know the tangent of 35 is going to be equal to h divided by 4.702, which means h is going to be equal to 4.702 times the tangent of 35 degrees, which is about 3.292. And that was kilometers. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.